Solve each of these equations to find the value of x. So here we've got x to the power of a half equals 5. So if you remember, something to the power of a half is the same as the square root of that number. So that's effectively the square root of something is 5, which you should be able to tell is 25. But we'll go through the working out so that it becomes clearer how to solve harder problems. So if we've got x to the power of a half, we need to return that to being x to the power of 1, or just x, which is what we need to find. So the easiest way to do that is to raise the whole thing to the power of 2. And if we do the same thing to the other side, then that gets us back to our x value that we're after over here, because a half times by 2 would just give us x to the power of 1. And then we've got 5 squared, which is 25, which is what we said the answer was a minute ago. Again, here we've got x to the power of a third, which is the cube root of x, is 4. So all we're going to do is raise both sides to the power of 3, because that will get us back to the x value that we need. So also raise this side to the power of 3, and we get 4 cubed is 64. And 64 to the power of a third is just the cube root of 64, which is 4. Now bear in mind, the reason we've done both of those there is because these two numbers multiply together to give us 1, hence get us back to just x, x to the power of 1. So we can use the same piece of information here. If I've got x to the power of 5/6 and I want to return it to x to the power of 1, I'm just going to raise it to the power of 6/5. We'll do that to both sides. So that will give me x. And then 32 to the power of 6 over 5. Well, remember, that's asking you to find the fifth root, and then raise that to the power of 6. So the fifth root of 32, all raised to the power of 6, where the fifth root of 32 is 2, and 2 to the power of 6 is 64. Again, here's another equation. Just like you would do with a regular linear equation here, we can begin by removing the extra term to give us x to the 2/3 is 16. And then we need to return that to x to the power of 1. So we'll raise that x to the power of 2/3 to the power of 3 over 2. And that will just give us x equals, well, 16 to the power of 3 over 2 is the same as the square root of 16, all raised to the power of 3. The square root of 16 is 4, and 4 raised to the power of 3 is 64. Again, remember here we need to raise all of this to the power of something to return it to x to the power of 1. So if we've got something to the power of minus a quarter, then we need to raise that to the power of minus 4, because those two things multiplied together will just give us 1. So that would be 2 to the minus 4. So we'd have x. And 2 to the minus 4, if you remember, if something's negative, it's 1 over. So 1 over 2 to the power of 4, where 2 to the power of 4 is 16, so it's 1/16. Again here, x to the power of minus 5 over 3, so we'll raise all of that to the power of minus 3 over 5. And we've still got, so we'll do the same thing to the other side as well. So 1 over 32 to minus 3 over 5 gets us back to x. If you remember, the negative term here tells us it's 1 over, so in effect the reciprocal of. So this will become 32 to the 3 over 5, which implies the fifth root raised to the power of 3. The fifth root of 32 is 2, and 2 raised to the power of 3 gives us 8. Slightly different type of question here. And we've got 3 to the power of x equals 81. Again, we've just got to state the value of x. Well, all we're going to do is write these as powers from the same base. So we know that 3 to the power of x is written in a base using 3. So if we write this as 3 to the power of something, then we must know what x is. Well, we know 3 times 3 is 9, times 3 is 27, times 3 again is 81. So 3 to the power of 4 is 81, therefore we'll say that x must be 4. So in effect, we kind of form a new equation for ourselves based purely on the powers once they're written from the same base. So again, here we've got this left-hand side written using the base of 2. So now we'll try and write this as 2 to the power of something. Well, 64 is 2 to the power of 6. So we'll write it like this. And now since they're both powers from the same base, we can just go and say, well, I know 4x plus 2 must equal 6. So from there we can solve that. Subtracting the 2, we get 4x equals 4. So x must be 1. Again, this time they're both on the same side, but if we just shift this lot over to the other side, we've got a similar kind of question. So we've got 5 to the power of x minus 1 is going to be equal to 25 to the power of x plus 4. This is already written in 5 to the power of something, so this also needs to be, well, that's 5 squared, and then it's all to the power of x plus 4. So if we tidy this up a little bit on the right hand side, we've got 5x to the minus 1 equals, we'd always multiply this lot together, so we've got 5 to the power of 2x plus 8. Since they're now both from the same base, we can just switch to looking at just the indices. So x to the minus 1 must be equal to 2x plus 8. And solving this from here, well, subtracting the x and adding the 8 over to the side tells us that x must be 9. Okay, final example. So write this. I can tell by looking at this is 27 and 9. So the base is going to be 3 that I'm looking to use here. So 1 over implies it must be 3 to the power of minus something. And 3 to the power of something to give us 9 must have been minus 2. So I've rewritten this part here as 3 to the minus 2. And that's still to the power of x. And this side I've got 3 to the power of, well, 27 is 3 to the power of 3, and that's still all to the power of 3x minus 10. I need to just slightly tidy it up before we do anything else. So we've got multiplying these together gives us 3 to the minus 2x. Multiplying these together gives us 3 to the 9x minus 30. Now they're both powers from the same base, and they're both equal to each other, so we can switch to just looking at them. We've got minus 2x equals 9x minus 30. So if we just add the 2x to both sides and add the 30 over, we get 30 equals 11x, and hence x equals 30 over 11.